So cache, and in that we are going to do today, we're going to start doing today, page replacement algorithms. Okay. Now the most commonly used we're going to do. What are these? These are FIFO, LRU, LRU, LFU, MRU, sorry, and then there is the IBM adaptive page replacement algorithm, and then the optimal page PRE is page replacement algorithm, also called Belades or clairvoyant page replacement algorithm. All of these are there. So we are not going to see what are all these things. Now, first things first. Oops, sorry. First things first. Let us start to know. Let us first just I'm sure that you know this, but let us first understand what is a page in this context. Is there anyone who can tell me what a page is?
Sir, is it a chunk of memory bit?
It is obviously a chunk of memory. So the first point I got was it's a chunk of memory. Yes, you're correct. It's a chunk of memory. But why is it there? Why do we need this chunk of memory?
So that our accessing time can be minimized
Can be
because the
optimized.
area.
Can be optimized. Yes. Access time optimization. See, basically what happens is, oh, basically what happens is that when you are, why do you need to page? The first of all, obviously, hierarchy is there. CPU, cache, main memory, and there. Now you see when you are, and we all know that we need to swap data from main memory into the cache so that you can get them into the CPU. The CPU can work with it. Now, if we are doing it in a, so for the swapping, imagine if you're doing it too small, that leads to many swaps. Correct? If it's too small, the memory chunk that you are swapping, by chunk I mean a certain amount of data, if you are swapping it and in too small a quantity, what will happen? Many swaps will have to happen because several different programs will be using data, and several different programs will have to be accommodated. So this is going to happen. On the other hand, if it's too large, okay, that means it is hard to fit in data of different programs. Then also this also may lead to many swaps. Why? Because let us say that it is a large enough size, it's a very big size of chunk of data you've brought into the cache, then and the CPU obviously is running more programs than one. Definitely, it's a multitasking CPU, so basically it is running more programs than one. And as such, what is happening is if you are swapping it, you're giving it. So basically, let's say you have brought in a large chunk of data, and that is useful for one program. The other programs need to use the cache. So either you deprive the other programs, which is obviously not possible, but then to actually service them, in that case you would definitely need the cache for that also. So if you're using large chunks, you have to put the data out and bring the next data in. Again, you have to bring it out. So that means that when you have a cache situation where data or needed by several programs, data from main memory is residing side by side for several programs. This situation is basically, uh, if it is too low, it can be achieved, but with a lot of swaps because many of the data won't be found in cache. If it's too large, then many of the programs won't be able to be serviced properly. So that again, it will lead to more swaps, etc. Okay, so that is why this access optimization is going to be there. Correct?
Yes, sir.
Okay. Now, as it stands, so these are now when you are replacing the pages. Now, the pages can't be allowed to remain in memory for a long time because you'll be needing the data. And in any case, how did we see that it was happening? So let us say you go into the cache, you don't find it. So then you go into the main memory and you find it there. You locate it there, you bring it in, and you also put it in cache so that next time you want it, it is there. And so how we do it? Spatial and temporal, spatial and temporal locality of reference we already talked about. Now, so that is fine. But the point is then how do we replace the Amrita Sokul is coming in now. So how are we doing this? This is everybody knows this. This is first in, first out. What is first in, first out? First in, first out means simple, as you have done in data structures also. The least the latest data that has come into the cache. Okay, so that will remain there. Remember, we are not doing last in, first out. We're not doing first in, last out, as we do in case of a stack. This is FIFO, not FILO. Have you noticed this? You are perhaps doing FILO and LIFO in data structures, yes?
Yes, sir.
But this is not FILO. This is not LIFO, or that is LIFO or LIFO or PHILO or FILO. It is not that. Remember, this is first in, first out. That means that what is it here? FIFO, first in, first out. That means that those which have been coming in first, they will be exiting first. It's like a queue. You've done a queue?
Yes, sir.
Okay. It's just like that. So what is the utility of the FIFO arrangement? Well, it's a very simple assumption that those that are being used inside the cache, if you the I mean, those that have come in earlier, those will be needed least because they've come in earlier. So the program is running, it requires some data. So where do you get the data from? You get it from memory. When do you need it? When it is current, you need it now. You don't need data which is old. So the assumption is that whenever the cache is full, see, nothing happens if the cache is not full, mostly. Okay. When the cache is full, new data has to be brought in, especially when there are requests. So how do you bring in the new data? In FIFO, the first ones that have come in, that is the ones that are most old, those will be thrown out. Understand? Do you understand this, Shushma? Did you understand this, Sriporna?
Yes, sir.
And who else is there? Muhammad Kostab. You guys have understood this, FIFO? Okay. Now let us look at another one, LRU. LRU is least recently used. What is this least recently used? So whenever you need to replace some data in cache and there is not enough space in cache, then you keep the you keep the sorry you sorry, just one sec. Yeah, you keep the recently used ones. Okay. Or rather, sorry, you throw out the list recently. You throw out the recently used ones. Okay. So why is that the case? When you are throwing out the least recently used, because if see, imagine that you are using um, imagine that that you are say you are needing some data in some program. You need some data. The least recently used ones are what? Those they may have come in any order whatsoever, but they have been used not very frequently, because least recently used means that they've been sitting idle for a very long time. So whether they are needed at all or not, okay, whether these are needed at all or not, there's a big question on that. They've come in, obviously. It was their turn and they've come in. But then after that, if they have not been used properly, or if their uses were not um, needed, then they'd be sitting idle. And they obviously, the least recently used queue would be that. So that is why when you need to throw out something and put in something else, you choose the ones that are least recently used, throw them out, and in their place, you bring in the data. Okay,
Yes, sir.
good. Next one is least frequently used. There's a difference between these two. Least recently used obviously talks about time. Least frequently used means, so this is least frequently used talks about the number of times. Now, there may be some data which has been used, say, 3 cycles back or 30 cycles back, not very recently used, but they have been used, say, 100 times. Other data are there which have been used recently, but not very not very frequently, like just once or twice or what. That's it, just once. I mean, if you brought in cache data, that means there was at least one need for it. Otherwise, you would never have looked for it in cache or brought it in cache. Yes, you can obviously. I mean, you are transferring a block, so it may be that some data of the block will may not be required at all. So in the cache, when the data comes in the cache, it may reside there and then never be used. There may be, but normally, the algorithms, the swappings, etc., are very well thought of and very well designed. So, normally, if the data is available in cache, you can safely assume that there was at least one use of it, at least one use. Otherwise, you would never look for it in the cache. You can safely assume that, but it's not always true. But there you are. Another thing is that, so least frequently used gets rid of that. Now, in the first three, what are the advantages and disadvantages? First in, first out does not mean you are throwing out the most unnecessary data. Now, no data is unnecessary, mind you. I'm only saying comparatively. First in, first out doesn't always throw out the data which is least needed. It may very inadvertently throw away data that was very much needed and had come in at the start. So it's a big failure of FIFO. Regarding least recently used, that also suffers a bit from that. Although out of the FIFO and LRU is better. It is better than this. Okay. The reason it is better than this is because LRU, by design, the LRU algorithm is least recently used, right? Not first or last or whatever, least recently used. It is most likely to keep in the important data in cache than FIFO. Then there is a least frequently used. That's good. That overcomes the troubles that you can face with FIFO and LRU both. It talks about how frequently the data is used. Sometimes that is also a problem. For example, a data has come in whenever it has come in. Let's say it's come in whenever it has come in. Say it's come in recently because it is being needed. It will now be needed in the future. It will now be needed more and more. But in any given time span, so far, it has not been used that frequently. LFU will chug it out. Doesn't mean that it'll never have to bring it back again because it just saw the number of times, the usages for the number of times. It did not see anything else. So you can imagine there is definitely a disadvantage there. So you have the IBM adaptive page replacement algorithm. So IBM adaptive page replacement algorithm works as follows: keeps track of both LRU and LFU. So it tries to see which has come in most recently, also tries to see which has been used most frequently, and all in all, it also tries to see which has come in first. Based on these judgment, it tries to determine how much necessary is the data inside the cache. Combining the analysis of both, or rather all three of definitely LRU and LFU and some of FIFO as well, it tries to see that. And once it is determined, then it can. Oh, are you guys still there? Are you guys still there?
Yes, yes, sir.
Okay. Yes. Sorry, let me just put it in the don't disturb mode. I don't know why I did not do that in the first place. Just one sec. Yeah. Okay. Right. Now, so this is the adaptive PRA, page replacement algorithm by IBM. Mind you, when you are writing it in assignments and especially in the exam copy, never write PRA, page replacement algorithm. If you have to use PRA as a short form, at least use the entire term page replacement algorithm first, within bracket write PRA, and then from there on start using that. Okay. Anyways, the next one is MRU. If LRU is least recently used, you can understand that MRU is most recently used. Now you may wonder, sir, what is the idea behind this most recently used? Why are we going to discard most recently used? The idea behind that is as follows. Idea behind that is as follows. The idea is that the most recently used ones, and there are obviously ones that are not been most recently used, they have been residing in the memory for a long time. The most recently used ones are the least needed. That is why they have not been needed before, and that is why the other ones, the ones that have been residing in memory for a long time, they have resided in memory traditionally for a long time because they have been needed again and again and again and again and again. So it may be that they have not been most recently used, but they are residing there because programs as a whole need them a lot. And this is true for certain types of data. For example, there are certain types of data that are used by uh, programs which need to, check upon the system from time to time and can carry on from the last part that they had used, so on and so forth. Their ways are quite different to the ways of the other programs. They can keep data alive for a long time. By alive, I mean data that is necessary for them can reside in cache for a long time. They may not need it for a long time, and suddenly again it may need. For example, if you have a program that looks after the health of your PC for many different cycles, it may be just inactive, and but it needs the data.